The next question is a problem solving question. John buys an ice cream machine for 2000 Rand. He buys it on a hire purchase agreement and agrees to paying it over 2 years. The interest rate is set at 10% per annum. So, they've given us the price of the ice cream machine. They've given us the number of years and the interest rate. They're giving us a formula as well. What is this formula? SI is simple interest. You can make a note of that. P is going to be the price of the item. R is going to be the interest rate. And N is going to be the number of years. So simple interest is equal to the price times the interest rate times the number of years. So calculate the interest earned. So that is just the simple interest earned, which is SI. So all you're going to go ahead and do is write the formula P times R times N. The price of this item is 2000 Rand times the interest rate of 10% times the number of years, which is 2 years. And your simple interest value, or John's simple interest value, will then work out to 400. So the simple interest value is 400 Rand. Now, calculate the total amount John will pay. Now, this is an interesting question. They saying that he's gonna pay 2000 Rand for an ice cream machine, but interest works where you are being charged money for borrowing money. So you're not gonna just pay back 2000. You're gonna be paying back an amount of 2000 plus the 400 interest that you've calculated in the previous question, and that's going to be 2400 Rand. So John is paying back 2400 Rand with the original amount and the interest amount. We're now working with some integer calculations. Let's look at our first one. When working with integer calculations or any long sum calculations, I highly recommend that you start by writing the question down first and then choose a part to work with. Don't work it out separately, but work it out in the sum itself. For example, let's say you decide I want to work out 4 plus 7, right? You want to work out 4 plus 7. You're not going to go ahead and write down 4 plus 7 somewhere else and then work out the answer and then come back and then go back and go all over the place. What you're going to do is you're going to work it out in this spot over here. 4 plus 7 is going to be 11. So write it underneath that. And there was a bracket around it, and outside that bracket was the number -3. So notice how I'm doing it in the space below the original sum. I'm not going and doing it there. I'm not going and do it there. I'm not going to do it there. So keep it going downwards. That allows you to track any mistakes. Next, we have brackets. Brackets means multiplication. -3 times 11 is going to be -33. And that sum is done. Simple as that. Our next one. Once again, working downwards, we decided to do this first. Because it's inside the brackets. You're going to sort out what's inside the brackets before you come out of the bracket. -2, -8. That's going to give you -10. We have the same sign, so you can add the number. You keep the sign, add the number. If you're confused, you may work with your calculator to see it's giving you that answer. and that's going to be in that same brackets, and here we had a 3 outside the bracket. What do we do next? 3 times negative 10. So 3 into negative 10, which gives you negative 30. Please do not go ahead and type this question in the calculator. Even though it gives you the same answer, I can tell that you've used a calculator. So can the examiner and the moderator, and they will know that you don't understand how to solve this. You've just used a calculator. And you will not be awarded full marks for that. In fact, you will have marks deducted on the basis of not understanding the concept. So even if you have to put every step in the calculator, it's fine, but show each step so that we can track that you've learned how to at least follow a procedure. Right, let's look at the next one. This is negative 5 brackets. Here we have 3 times negative 7, which is going to be negative 21. So putting it in your calculator, it gives you that negative 21. Straightforward. Notice how I've brought the negative 5 down. The brackets are still here and I'm still continuing. I'm not writing 3 times negative 7 here and writing negative 21 and then writing negative 21 somewhere. I'm doing it in one sequence. I cannot emphasize that enough. And then negative 5 times negative 21 will be 105. So your final answer is 105. Next one. We now have a simple question here. This part is not so difficult. This one might throw you off a little bit. Negative 3 squared. I want every one of you to take out your calculator and type this with me. Negative 3 squared. Now first, ask yourself, does this look like the same thing in the question? Just using your eyes, is this the same thing that's written in that question? The answer is no. There's a brackets missing, and that is important because as I've written it, the answer is negative 9. But if you include that brackets, the answer is positive 9. So ensure that you are entering this correctly into your calculator. This becomes a value of 9. And then we bring down our other values of plus 4 minus 8. According to BODMAS, you do the addition next. And 9 plus 4 is 13 minus 8. And then you can go ahead and say, right, 13 minus 8 is going to give you 5. And then you are completely done with the sum. The next one. Working linearly, going downwards. I cannot stress this enough. Enter each thing separately into the calculator. It's fine. The square root of 25 is going to be 5. Negative 3 squared. Now notice how there's no brackets because there were no brackets in the question. Negative 3 squared is negative 9 plus 4. And now you have to put this in your calculator and work it out. You can go ahead and type this straight into your calculator and it shouldn't be a problem, and your answer here is going to be 0. Okay, no stress on that one there, but ensure you are working linearly. Your answer should look like mine. Even if all the numbers are wrong, it should be in at least the same place. Next one. The cube root of 125. How do you enter a cube root into a calculator? So you're going to look for a block that looks something like this. Either that one, or it could even have a little 3 there to allow you to enter a cube root. So in my calculator, it is over here. There we go. Sorry. It is shift there. There we go. Root of cube root 125. and that'll give you that 5. And if you happen to find the block version, this allows you to enter a 3 or a 6 or a 9 over here. You can enter whatever you want to, and it still works the same way. The square root of 25 is going to be 5, and the square root of 100 is going to be 10. 5 plus 5 is 10, minus 10 is 0. There we go. Work linearly, downwards. 2 cubed is 8. 2 cubed means 2 times 2 times 2. It's multiplying this number that many times. Taking 2 and writing it however many times this tells you. So taking 2 and writing it 3 times. So 1, 2, 3. And multiplying all of that. That is how 2 cubed works. So 2 times 2 is 4, and 4 times 2 is 8. It is not 2 times 3 equals 6. It is 2 times 2 times 2 equals 8. Minus the cube root of 64. So this is some number times itself 3 times. So 4 times 4 times 4 gives you 64. So the cube root of 64 is 4. And 8 minus 4 is 4. Right, for this video I'm going to try and go ahead and finish off question 16 and 17. Question 16 is basically a repeat of something we've done earlier. But this time we're asking you, negative 3 plus something has to equal to 0. Negative 3 plus something has to equal to 0. What do you think that's going to be? Negative 3 plus 3 is going to equal to 0. That's an additive inverse. See, a number plus additive inverse equals 0. Alright, and for b we have some number times 3 over 2 to equal to 1. Doesn't that remind you of your multiplicative inverse, which is 2 over 3 times 3 over 2 to give you 1. You flip the fraction. Alright, this was our additive, and this was our multiplicative. Number 17. Interestingly, we have this. A fraction with a square. For this, do not use your calculator. We're going to learn how to do these things. The way we're going to do it is we're going to distribute this to all the parts of this fraction. So the 2 will go to the 1 and the 2 will go to the 3. So you have 1 squared over 3 squared. And that's going to equal to 1 over 9. Okay? Cool. We're going to do the same thing with the square root of 4 over 9, where the square root in itself is going to be distributed to the 4 and the 9. So now we have the square root of 4 over the square root of 9. And there's a plus sign in between. Remember, we're working linearly, so it's just getting carried down. The square root of 4 is 2, and the square root of 9 is 3. Now you have 1 over 9 plus 2 over 3. Right, 1 over 9 plus 2 over 3. We can't work or add a fraction if the denominators are not the same. So 9 and 3 are not the same number. We will need to make them the same number. And if you've noticed it, that 9 is a multiple of 3, which means if you multiply 3 by something, it's going to give you 9. So what is that number? 3 times 3 is equal to 9. And that will make the denominators the same. But if you're multiplying the denominator of a fraction by something, you've got to multiply the numerator as well. And that will leave you with 1 over 9 plus 2 times 3 is 6 over... 3 times 3 is 9. Now that the denominators are the same, you just go ahead and add the numerators. So it's going to equal to 1 plus 6, which is 7 over 9. And your denominator remains the same. Now, sorry about that. Pause the video and attempt this question. Okay, you should be done after you've paused it for at least 5 to 6 minutes to truly attempt this question. We're going to distribute the cube root to the top and the bottom of this fraction. So now we've got the cube root of 64 over the cube root of 125 minus the fraction of a half. The cube root of 64, as we've seen, is going to be 4. And the cube root of 125 is going to be 5 minus the fraction of a half. Now, how do you work this out? They are not the same denominator. And 5 is not a multiple of 2. But if you look at the number 2 and the number 5 and you do their multiples, 2, 4, 6, 8, 10, 5, 10, 15, you notice that the number 10 has appeared twice. It's common, meaning that both numbers can be multiplied to reach 10. So let's start with the number 5. How can the number 5 become a 10? If you times it by 2, 5 times 2 is 10, and you'd need to do it on the top as well, times it by 2. How can the number 2 become a 10? You times it by 5, times it by 5, and then you'd have 8 over 10 minus 5 over 10. Now that we have the same denominator, you can do your subtraction. 8 minus 5 is going to be 3, and your denominator remains the same. There you go. Right. We're now working with these questions here. 0,3 times 0,5. We need to first learn how to convert this into a fraction. This is called a decimal. We will convert it into a fraction. So we do that by checking how many numbers we have after our comma. In this case, we have 1. Here we have 2. Here we have 1 again. Here we have 2 numbers. Here we have 1. So this is important because when converting to a fraction, it tells us what our denominator should be. For example, if the number has 1 decimal, the denominator will have 1 0. It'll be a 10. So let's put this here. It'll be a 10. And our numerator will just be whatever that number is. So it's 3. 3 over 10 times. The next one is 5 and 1 decimal, so it's going to be over 10. So recap: 1 decimal, 1 0. 2 decimals, 2 0. 1 decimal, 1 0. And whatever this number is, just goes on the top. Now that you have this, we just multiply in fractions. When multiplying, we multiply straight across like this here. So it's essentially 3 times 5 over 10 times 10, which works out to 15 over 100. Let's keep the momentum going. Equals. This is going to be 2 decimal places, so over 100. And those two numbers are 65. So 65 over 100 times 0,2 has 1 decimal. So 10, and the number is 2. Multiply straight across equals to 65 times 2 over 100 times 10. And that'll work out to 130 over 1,000. If you put that into your calculator, it'll simplify for you. 130 over 1,000 works out to 13 over 100. And you can write that as your final answer. The next one. One decimal place here and 1 decimal place here. meaning we're going to have over 10 on both. We're going to have a denominator of 10 in both. This one, straightforward, it's an 8. However, here we have a 1 before the comma, so this is new. We know the 4 is going to go there, but this 1 is also going to go there. It's the same thing as if we put the 0 here, but 0, 8 makes no difference. 0, 8 is just 8. And if I gave you 0, 8 rand, it's still 8 rand. But if I gave you 80 rand, that would have been 80 rand. Right, so that's fine. So 1, 4. Now we can multiply. So 8 times 14 over 10 times 10. And for this year, 8 times 14 is 112 over 100. And 112 over 100 can be written as 28 over 25. Next one, 0,3. Let's pick it up. I'm sure you know how to convert this to a fraction by now. It's 3 over 10. Remember the bracket with the square. Minus 0,1 will be 1 over 10. Remember the bracket with the square. We've worked with brackets and fractions and squares before. We distribute this. So now we have 3 squared over 10 squared minus 1 squared over 10 squared. 3 squared is 9 over 100 minus 1 squared is 1 over 100. Your answer is 8 over 100. And then you can go ahead and divide this by 4 or simplify it in your calculator and get 2 over 25. So this is your 8 divided by 100 is 2 over 25. Next one. Keep it moving, guys. Let's get it going. 0,04 is 4 2 decimal places over 100 plus 0,2 is 2 over 10 squared equals, remember we're going to distribute the root sign to the top and the bottom, so the square root of 4 over the square root of 100 plus, distributing this, you get 2 squared over 10 squared, and that's equal to 2 over 10 plus 4 over 100. Can we add this? No, the denominators are not the same. So to make them the same, we will times this by 10, which would make that 20 over 100 plus 4 over 100, giving us a final answer of 24 over 100. There we go. Last one, guys. I think. Yeah. Let's work this one here out. We're almost at the end of this video. So equals 0,2, 1 decimal place, 2 over 10. Small 3 means cubed. Minus, this is probably a typo, minus the cube root of 27 over 1, 2, 3 decimal places, so 1,000 equals, distribute that, guys, distribute it, 2 to the power 3 over 10 to the power 3 minus cube root of 27 over cube root of 1,000. 2 to the power 3 is 8, 10 to the power 3 is 1,000, minus a cube root of 27 is 3, and the cube root of 1,000 is 10, equals, we can't work that out because they're not the same denominator, so you make them the same denominator, times 100 times 100, so you'd have 8 over 1,000 minus 300 over 1,000, and your final answer here will be minus 292 over 1,000. These can be simplified further. I just didn't, but they can. And they should be simplified further. Let's go ahead and simplify the next question. 6 squared plus 3 squared. Habit of working linearly. 6 squared is 36 plus 3 squared is 9. So this question wasn't too hard. You just had to square the first one, square the second one, and now you're going to add the answers. So 36 plus 9 is going to give you 45. Next one, the square of 64 is going to be 8. Plus the square of 49 is 7. 8 plus 7 will give you 15. Next one, let's go. 3 cubed, 27. Minus the cube root of 27, obviously 3. 27 minus 3 is going to be 24. Next one, now we have the laws of exponents. When the bases are the same and you're multiplying two numbers with exponents, all you have to do is add the exponents. So see, we have a 2 and a 2 and we got exponents. We're gonna go ahead and add them. So it's equal to 2 into 3 plus 4, which is 2 into 7. If you go ahead and write some massive number like this here, oh, okay, even if you write 128, you're gonna get 0 for this question. You haven't done what I've asked you to do. You haven't used the laws of exponents. So don't do this. Next, again, we've got the laws of exponents. This time, because we are dividing our terms, we are gonna minus our exponents. So it's equal to 5 to the power 7 minus 3. And that's gonna be 5 to the power 4. That's not very hard to do. So just practice. It's okay. Next one is 3 to the power 2 raised to the power 3. This is different because here we have two bases. Here we have one base and two exponents. So when you raise an exponent to an exponent, you multiply the exponents. So that's equal to 3 to the power 2 times 3, which is 6. You are multiplying them. Let's write the following numbers in scientific notation. The first one is this number here, 4,500,000, and we want to write this in scientific notation. The way we do this is first we identify where our comma is. Our comma is over here. We want to take this comma and put it in the most relevant place. There's no point in having a comma between two zeros or between these two zeros or at the end even. The comma should be in the most relevant place, which we can obviously guess would be maybe between the 4 and the 5. So generally we're going to try to just have one number and then the comma and whatever is your balance. So in this case it's 4 comma 5. So writing this in scientific notation would be 4 comma 5. This next part will always be the same, times 10 to the power. Now there's an exponent that we need to fit here. How do you get this? This exponent is going to depend on how many times the comma has moved. So in this case, the comma has moved from its original place here. It's moved 1, 2, 3, 4, 5, 6. So it's moved a total of 6 times. If the comma has moved to the left, as we see in this example, if it's moved to the left, then your exponent will be positive. That means if it moves to the right, your exponent will be negative. Okay, but now that we're done with the first one, let's try the next question. Our comma is over here. Where's the most relevant position? 6 comma 2. So let's put that down, 6 comma 2. The next part he said is constant. Now we need to know how many times it moves from the original position to the new position. So it's 1, 2, 3, 4 times. So it will be 4 times. And because the comma is moving to the right, the exponent is going to be a negative number. It's just following those few simple procedures or steps that will give you that answer, and then you're done with your science. For this question, I want you to just have a look at this number pattern, or this pattern 3, 6, 12, 24, 48. Take a minute and just try to guess what the pattern is. So how do we go from 3 to 6? That also allows us to go from 6 to 12. Pause the video, take a minute to try and get the answer. Now that you're back, it's simple. It's 3 times 2 to give you 6. 6 times 2 to give you 12. 12 times 2 to give you 24. 24 times 2 to give you 48. So what are the next two terms in the sequence? It's gonna be 96 and 192. State the rule in words. Simply multiply the previous term by 2. There we go. Take a minute, pause the video, try and answer some of these questions. Welcome back. So, simple. Study the pattern. We have a triangle. Matchstick, matchstick, matchstick. Next one, there's our 3 original matchsticks. They've added 2. Here's those 5 matchsticks. They've added another 2. They seem to be adding 2 matchsticks each time. Describe the pattern in words. Add 2 matchsticks to the previous term. Write a rule to find the number of matchsticks for any term. We're going to use the formula Tn is equal to Dn plus C. In order to do this, we need to know the first thing. What is our difference? What is the difference value? The difference value is how many this is changing by, and it is changing by plusing 2 matchsticks every time. So we're gonna start with our Tn formula. Tn is equal to Dn plus C. As mentioned, the difference is 2. So instead of D, we're gonna put in 2. We're now going to choose any one of these 3 patterns or positions of the pattern. Suppose I chose this one. In this one, we are looking at term 1, 2, or 3, and then there's the number of matchsticks. So the number of matchsticks in the first one is 3, then 5, then 7. So let's have a look at this one. This one says that you are in the second term and you have 5 matchsticks. So your n value is the term. The number of matchsticks is your Tn value. So this is your Tn value. We're going to go ahead and try and fill this into this equation, which leaves us with something that looks like this here. Instead of n now, we're going to put in that 2. Instead of Tn, we're going to put that 5. And now we're going to try and check. Now, we're going to check what value of C makes this equation true. So you do this by solving the equation. So let's have a look here. So firstly, 5 is equal to 2 brackets 2. Brackets means multiply. So 5 is equal to 4 plus C. We can take the 4 across. It will become a negative 4. And then our value of C is equal to 1. From there, we can rewrite our final equation. Tn is equal to 2n plus 1. So the plus 1 comes from here. And that's your answer. Write a rule to find the number of matchsticks. Here we have our answer. How many matchsticks will be used for the 10th triangle? So here, now that we have our rule, Tn is equal to 2n plus 1. The 10th triangle is simply meaning the nth triangle. So we just sub in 10 over here. So Tn equals 2 into 10 plus 1, which is 20 plus 1, which is 21 matchsticks. So 1, 4, 9, 16. This is our pattern. Let's check the position of the pattern. This is the first position, second, third, fourth. Now the question is, how do we get this pattern? You can try adding, you can try multiplying, you can try dividing, but it won't give you this pattern. This is a unique pattern. It's based off of your square numbers. What does that mean? It means that we are considering the position of each term. So for example, the first term is term 1. If you square this, 1 squared is equal to 1. The second term is term 2. 2 squared is equal to 4. 3 squared is equal to 9. 4 squared is equal to 16. So we are just squaring the position of the term. So the way we can write this is Tn equals to n squared. Basically, we're squaring the position. The term is equal to the position of the term squared. Use your rule to find the 8th term. So that's going to be simple. Tn equals to n squared. We're now going to put in 8 to find the 8th term. So Tn is equal to 8 squared, which is going to be 64. Explain why your rule is correct. So why my rule is correct? It's because it gives me the correct outputs. It works with the values that I'm putting in. This is a bit of a silly question. If it works, it works, alright? So I'm not really gonna go ahead and answer that. And you don't really need to stress on that. This next question wants you to find the value of an expression if certain values are given. X equals 2 and y equals to negative 1. So the expression here is 2x plus 3y. In order to find the value, we basically need to get rid of the letters. And this helps us do that because the value of this is a specific number which we don't know. So we need to get rid of the letters. So all we gotta do here is take these numbers and substitute them in the matching places. So where there's an x, we're gonna put a 2. Where there's a y, we're gonna put a negative 1. So let's have a look here. So 2, whenever you substitute, put a brackets, and then you got this negative 1, and 2 times 2 is 4. 3 times negative 1 is negative 3, and your answer is 1. So the value of the first expression is 1 if x is equal to 2 and y is equal to negative 1. Next one. This is something squared. It's going to be 2 squared minus negative 1 squared. And that's going to be 4 minus 1. If you put this in a calculator, you'll just be able to see what I'm talking about. And that's your answer there. For the next one, it's 4 into 2 minus 2 into negative 1 cubed. 4 times 2 is 8 minus 2. Negative 1 cubed is negative 1. So it's 8 plus 2. Let's simplify the following expressions. We have 2 terms divided by 1 term. 2 terms divided by 1 term. I'm going to simplify this by splitting it up. The first term over the denominator and the second term over the denominator. So it's going to look like this. 6x cubed over 3x plus 9x squared over 3x. Okay, now we're going to divide this by this and this by this. So what's 6 divided by 3? That's going to be 2. What's x cubed divided by x? Remember, we're going to follow the law of exponents where there's an invisible 1 here. And when you're dividing, you subtract the exponents. So it's x to the power 3 minus 1. It's basically x to the power 3 minus 1. So that'll give us x to the power 2 plus 9 divided by 3. 3. And x squared divided by x, 2 minus 1. So it's basically going to be x to the power 1. We're going to stop there. These are not like terms. We cannot go any further. Pause the video, attempt this one. Right, let's split the fraction. 8y to the power 4 over 4y minus 12y to the power 3 over 4y. 8 divided by 4 is 2y to the 4 divided by y to the 1. You subtract the exponents of 4 minus 1 is 3. So it's going to be 2y cubed minus 12 divided by 4 is 3. Y3 divided by y1 is 3 minus 1, so y squared. Unlike terms, so we can't simplify any further. We've seen this before. We got an exponent outside. We're gonna distribute it to the terms inside. So this becomes 2 squared and x squared. 2 squared is 4 and you got x squared. Pause the video and try this question. Distribute. 3 cubed times a cubed. 3 cubed is 27 and you got a cubed. Right, let's try this question here. We have the square root of 49x squared. For this, we're basically applying the square root to everything. It's the same as the square root of 49 next to the square root of x squared. The square root of 49 is 7, and the square root of x squared is going to be x. A square and a square root will cancel off. So the square root of a square is the number itself. Alright, just let's do a few more exercises on that. The square root of x squared is x. The square root of y squared is correct, y. The square root of x to the power 4 is x to the power 2. We're gonna divide that exponent by 2. The square root of y to the power 10 is correct, y to the power 5. The square root of x to the power 12 is x to the power 6. Right, let's go. Now when you have a cube root, what's the cube root of x to the power 6? You're gonna divide it by 3 now because it's a cube root, so it's x to the power 2. If you add the cube root of y to the power 12, it's y to the power 4. Now let's have a look here. Now you got the cube root of 8 and the cube root of y cubed. The cube root of 8 is gonna give you 2. A cube root and a cube will cancel, so that's just gonna give you y.